Here we want to evaluate the piecewise function for f of -3, f of 0, f of +3, and f of 4. And we have this piecewise function. We're told that the function is going to be x squared minus 1 when x is less than -2, -3x plus 2 when you have -2 is less than or equal to x, which is less than 3, 5 when x equals 3, and the absolute value of x minus 4 when x is greater than 3. So let's start with f of -3. We need to think about our input, -3. So that's saying that -3 is our x value. And we want to think about these different pieces of the domain. Where does -3 fit? Well, -3 is less than -2. So we're looking at this top piece. And thus we're going to plug in -3 for x and x squared minus 1. So I plug in -3 for x, and then just evaluate. -3 squared is 9, and 9 minus 1 is 8. So f of -3 equals 8. If we look at f of 0, looking at my input of 0, that's going to be the x value, and thinking about, well, where does 0 fit in the different pieces of the domain? Well, 0 is greater than or equal to -2 while simultaneously being less than 3. So it fits here. -2 is less than or equal to x and less than 3. So we're going to plug in 0 for x into -3x plus 2 and simplify. So I'm plugging in 0. And I'm going to simplify. -3 times 0 is 0. 0 plus 2 is 2. So f of 0 is 2. If we look at f of 3, well, we're thinking about where our input 3 fits in the different pieces of the domain. Well, 3 equals 3. So we're looking here at the third piece, x equals 3. And when x equals 3, we're told that our function equals 5. So very simply, f of 3 equals 5. Lastly, f of 4. Our input is 4. We want to consider where our input 4, or our x value of 4, lies in the pieces of the domain. Well, 4 is greater than 3. So we're looking at this fourth part of our piecewise function. And we're going to plug it in to the absolute value of x minus 4. So I'm plugging in 4, absolute value of 4 minus 4. Well, and the absolute value 4 minus 4 is 0. And the absolute value of 0 is 0. So f of 4 equals 0.